Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 23, 2025, about 3 days ago. The striking result is that capable reasoning models make poor slop judges. In zero shot, GPT-5 posts precision 0.38 and recall 0.12. The paper is titled, Measuring AI Slop in Text, and as we'll see later, the framework turns a vague complaint into measurable dimensions. In short, this paper builds a multi-axis taxonomy, gathers span-level human labels, shows simple metrics are weak, and tests detectors from linear models to a fine-tuned QN7 B-span extractor. The introduction set up the taxonomy and aims. Figure 1 shows span annotations on a human-written news article, with red marking slop spans, green marking human writing cues, and yellow showing overlap. The highlighted labels emphasize density, verbosity, tone, relevance, coherence, and vagueness, which differ from what signals human writing. This contrast motivates span-level labeling because it localizes specific problems rather than forcing a single document judgment. Well, Figure 1 showed why span labels matter. Table 1 organizes the taxonomy, grouping codes under information utility, information quality, and style quality. The most cited elements are relevance with 9 mentions, and factuality and repetition with 7 each, followed by coherence with 6, and verbosity and density with 5. Granular style cues include templatedness, fluency, word complexity, and tone, which signal slop because they degrade clarity, usefulness, or trustworthiness in different ways. Okay, Table 1 laid out the taxonomy. Table 3 reports agreement and prevalence for the codes. Theme level Krippendorf alpha MASI lands near 1/3 to 1/2, which signals partial overlap but not full consensus. Factuality and bias show the strongest GWET AC1, about 0.76 and 0.67, while tone is low at about 0.20. Relevance appears often, roughly 68%, yet its agreement is modest, so judges noticed it but did not align perfectly. So while Table 3 showed who agreed with which codes, Figure 2 shows which codes actually drive slop judgments. Across all data, relevance, density, and tone carry the largest positive log odds, which means these issues most strongly push a text toward slop. In the news panel, style and utility matter most, with coherence, tone, density, and relevance standing out. In the MS Marco panel, factuality and structure dominate because short answers reward correctness and organization over polish. So, Figure 2 showed which codes drive slop. Table 6 maps the taxonomy to automatic metrics and flags, which codes significantly predict the slop label. Density and relevance are marked significant, with proxies like surprisal for density, while bias has a subjectivity lexicon and structure links to compression and templates per token. Crucially, coherence and aspects of tone are significant, yet lack reliable metrics, so human span annotations remain essential. Alright. Table 7 reports how models judged slop and extracted spans. The left panel shows binary slop assessment. Kappa values sit near 0, models flag slop in only 3 to 8% of cases versus humans at 34%, and precision and recall stay low, for example 0.38 and 0.12 for GPT-5. The right panel lists span extraction. GPT-5 stays around 0.14 precision, and 0.11 recall even with few shots, while a fine-tuned QN7B reaches about 0.32 precision and 0.30 recall. So while Table 7 showed models struggled to judge spans, Figure 10 shows precision recall curves for linear models over automatic metrics, with a red dashed line marking class prevalence. In the news panel, area under the precision recall curve is about 0.58 versus prevalence near 0.34, so precision roughly doubles the baseline. In the MS Marco panel, area is about 0.55 against prevalence near 0.27. These gains help, but they are not strong enough for reliable slop prediction. Alright, 2 takeaways stand out. A clear multi-axis taxonomy plus span annotations make slop concrete, and the strongest drivers are relevance, density, and tone. Automatic metrics and capable models remain weak judges, so better domain-aware measures and human-in-the-loop evaluation matter. Thanks for listening. I am Alex, and this was the AI Research Roundup.